the radius of the Earth's nearly circular orbit around the Sun is 1.5 times 10 to 11. Find the magnitude of the Earth's velocity, the angular velocity, and the I just lost the word.
Centripetal.
Yeah, thank you. Acceleration as it travels around the Sun. Assume the year is 365 days. So I did part A and B, and C, my answer didn't really make sense, and when I looked in the back of the book, it was not right. So I'm just trying to figure out what I'm doing wrong.
What do you get for the velocity?
The first one, the 2, 9.
29885.77 squared all over 1.5 times 10 to the 11th. That should get you your answer. Because you have it right here, the v squared over r. So that's going to be velocity going this direction times your r. And so that's what that velocity right there is the v going in that direction.
Yeah, I was using... You're fine, no worries.
Hola, ¿cómo está?
Is there room?
Yeah.
Oh, yeah.
Yeah, come on in.
I'm learning physics.
How you doing? I'm Chris.
Scott.
Wow.
So you dropped that class?
Yeah.
Is that you dropped the class?
Yeah, I talked to him and I'm like, yeah, I take this class and I mean it's fun, but I don't want to stress out about it. And he's like, okay.
No, that's fine. Sorry about that.
No, it's fine.
They're watching you, by the way.
Why?
So they do this for
That one's mine.
the online stuff.
Actually, no, that one's yours.
They do this for online,
Mm-hmm.
so that when people have questions and they can't come to the meeting center. Thank you, by the way.
Yeah.
Freaking legit.
You didn't give me any.
You want some?
some?
No, I'm kidding.
Yes, you got the stuff. So they can go online and get help just watching the videos.
Oh, cool.
Now, when I saw in the back of the book the units for angular velocity, which one? It's not meters per second.
Give napkins.
Oh,
Hold on.
Okay.
Okay.
I think if I just understand where these concepts are coming from, I can better figure it out. Because I got this with like kind of the help of neighbors, just like, well, I think we're supposed to do this. Okay, yeah, that's right.
So that, oh, you can take that chair if you want. That's a cool chair. Cooler chair. Okay. So angular velocity is very similar to regular velocity.
Okay.
Oh, in linear world, you have position and velocity and acceleration. In circular world, or the in angular terms,
Yeah.
you have the same thing, but it's curved. So you have theta. So around a circle, you have 2 pi. That's like your
Okay.
distance. You have omega, which is how many of these you're going around in a circle in a second. And you have alpha, which is how fast you're going, how much you're speeding up around that circle.
Gotcha.
The units, meters per second, meter per second, and meter per second squared. These, you're just going to change out meters with radians. Radians per second, rads per second squared. So it's like if you have a line and a circle.
Mm-hmm.
Theta is just how far you're going along that circle, and x is just how far you're going in that line.
Okay.
Omega is radians per second. So let's say you want to go around the circle once, or you want to see how fast you're going around the circle, right? You would count how many radians you're passing in a second. So
That's
let's
your
say
speed.
that's your speed.
Okay.
So the units are radians per second. then same thing with omega. And the good thing is you can convert from linear to angular, from angular to linear. You normally just have to tag on an r. So if you know the radius of the circle, you can find the velocity and the acceleration and the position. The reason why you don't need r for this is because this angle does not depend on this length. This angle is the same for this length or that length, or from here to the edge of the galaxy. It's going to have the same theta, same omega, and same alpha. For example, you'll probably do a problem later on in the semester where you find, it's actually pretty good one, yeah. You found omega of the, yeah, that's it. Yeah, that's what I was thinking of.
Okay.
So omega, it's a really tiny number. You wouldn't imagine that because the Earth's going really fast.
Yeah.
But if the more you think about it, the more like, yeah, you know, that makes sense because it takes a year for the sun to go around for the Earth to go around the sun.
So now, why is... Do I have my symbols wrong? I have my symbol wrong on that one. 'Cause distance over time is... Oh, wait, what's distance over time? Is that theta or...
Distance over time would be omega, so that's your
Omega.
radians per second, or velocity, which is your distance over time.
So this one's W. Alright. I don't think I still have these right. So right here, my distance over time, that's not my velocity, right?
Yeah, that, or distance over time is velocity,
Yeah.
so that's just your v. The omega is radians over time.
Alright, so angular velocity is omega, right?
Yeah.
Okay. Now, why, I guess it's back in the book says meters per second for this velocity, that makes sense. That's radians per second, okay, that makes sense.
Mm-hmm.
And meters per second squared. Would that one be right? Meters per second squared?
Yeah.
Okay.
So your centripetal acceleration, is it looking for alpha or centripetal acceleration?
Centripetal. So that's...
Oh yeah, that's good. Yeah, that's right.
That is right?
Yeah, sorry.
To have those
So that's
two symbols
centripetal,
next to each
or
other?
that's centripetal, and that's omega, alpha.
Alpha.
That's
okay.
your angular acceleration. So if the Earth is speeding up around the sun, like
Mhm.
speeding up from this speed to faster, 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 then it has alpha. If it's just got the centripetal force, centripetal acceleration, trying to like pull it out, then that's your AC. So in the case of the Earth around the sun, it's not accelerating angularly, it's accelerating centripetally.
That's interesting.
It's kind of like you going around, it's like NASA. Do you watch NASA? Formula One? Dirt bikes?
Okay, dirt bikes.
Dirt bikes, okay. So let's, the circus, got it.
Perfect.
You know that big ball of death that they have at the very end where they have like the 5 motorcycle guys go in and then they do the loops? What's keeping them up and keeping them alive is centripetal acceleration. They're going the same speed, like you have your sphere, and they're going around the equator of the sphere.
Yeah.
They'll be going the same speed, like 30 miles an hour or so, something pretty slow. And they are going around the circle. It's got 2 pi radians, because it's a circle. But they're staying at 30 miles an hour. What's keeping them out is the centripetal acceleration. So depending on how big the circle is, it's going to make the acceleration greater because their velocity is constant. So you could put it in there if it's like 10 meters. You could put the velocity in there divided by the meters and you still have an acceleration. It's like when you go around a corner in a car, you feel that force going out. You're not speeding up, you just got that urge to go that way.
Gotcha. Okay. Makes sense.
Yeah.
I think 25 is similar.
We actually did the math one time and they're going like 25, 30 miles an hour. So it's like really not that fast.
Like, it looks fast, but it's not.
Like even to get her up around that loop, they only have to be going like 30 miles an hour.